Let's see if we can explain the concept of absolute versus relative error. You might have heard the saying, everything is relative. So what do we mean by that? You might be asking the question, is 90 degrees hot? Is that a hot temperature? Well, 90 degrees is the actual measurement, but you might want to judge it relative to something else. So 90 degrees Fahrenheit relative to a typical fall day in San Diego, yes, the 90 degrees would be much hotter than you'd expect. Relative to a summer day in Las Vegas, then no, 90 degrees would be actually fairly cool compared to the typical weather there. Another example, what if you missed 2 points on an assignment? Is missing 2 points really bad? Well, relative to the fact that it's a 150-point exam and you got 148 points and you only missed 2, then no, missing 2 wouldn't really be bad. If you were taking a 5-point quiz and you only got 3 points and you missed 2, well, yeah, missing 2 points is not such a great score. So we've seen this before in our percent error calculation video. This is a slide from that video. And being off by 1 centimeter can mean 2 different things depending on whether you are building a 75-meter fence or a 25 centimeter jewelry box. One way to tell how 1 centimeter relates to the total measurement is by using a percent. So relative to 7,500 centimeters, 1 centimeter is 0.01%. Relative to 25 centimeters, 1 centimeter is 4%. So expressing something relative to another can be done as a percent. I also wanted to take a look at the word error. So we've looked at relative and absolute and what those meant. Relative error versus absolute error. The word error in this way, used in science experiments and measurements, is synonymous with the word uncertainty, which is a possible error. If you are uncertain to within 1 centimeter, then you have a possible error of 1 centimeter. For example, here we have a length of 56.8 centimeters, and your tape measure, the way the lines are, you can read it to the closest 0.1 centimeter. So your error or your uncertainty is 0.1 centimeter. That doesn't mean that you are 0.1 centimeters off. It means that you are within 0.1 centimeter of the measurement. If you wanted to indicate that, you can say that this length is 56.8 centimeters plus or minus 0.1 centimeters. So you're telling people that you took this measurement and you believe it's between 56.7 and 56.9 centimeters. So I want to contrast this with the word mistake. A lot of times in regular language, the word error means the same as the word mistake. You did something wrong, you pressed the wrong button, you wrote down the wrong measurement, and then you say, oh, well, I made an error. And scientifically, error is not the same as a mistake. If you measure 56.8 centimeters and you write down 65.8 centimeters, that's not what we mean scientifically by error. That would just be a mistake. You wrote down the wrong number. It doesn't have anything to do with the type of equipment you're using and how certain you can be with that equipment. That's just a mistake, so that should probably be done over. All right, to summarize the absolute versus relative error, get a little bit of a comparison here. Absolute refers to the actual error amount. So if your uncertainty or your error is 0.1 centimeters, that would be the absolute error. It doesn't factor in the measurement itself. If your tape measure measures to within 0.1 centimeter, that's the error no matter what measurement you take with that tape measure. And it has the same units as the measurement. So you're measuring something in centimeters, your absolute error is also going to be in centimeters. Relative, you can't figure out the relative error that a tape measure gives until you actually measure something, because that error of 0.1 centimeters, maybe the tape measure always has that error, but it's going to be different relative amount when you measure something large versus when you measure something small. So that 0.1 centimeter error has to be expressed relative to the measurement itself. And a lot of times we do that as a percent. And to figure out the percent, you need to use the measurement in the calculation and calculate what percent that 0.1 centimeter is of your measurement. And then when you are calculating that, the units of the measurement are going to cancel. So 0.1 centimeters over 14 centimeters, the centimeters will cancel, and the final units are going to be percents. So if you have the absolute error and you want the relative error, so you have the error expressed in the units of the measurement and you want to figure out the percent, the way you would do that, figure out what percent is that error of my measurement, you would take the error, divide it by the measurement, and then multiply that result by 100%. So this would be the fraction, and then you would multiply that by 100%. So you have 56.8 centimeters plus or minus 0.1 centimeters. This is your measurement, the 56.8. This is your error, the 0.1 centimeters. And the relative error would be that 0.1 over 56.8 times 100%. Or 0.002, the centimeters have canceled, and then it's times 100%, which would be 0.2%. Also, I've reduced the number of digits because the uncertainty we only know to one digit. Expressing this as 0.176% would not be appropriate. We don't have that much certainty in our error. So instead of writing 56.8 centimeters plus or minus 0.1 centimeters, we could also write this as 56.8 centimeters plus or minus 0.2%. That's our uncertainty expressed as a percent. What if we know the relative error and we want to get the absolute error? So this was the same equation as the previous slide, and we're going to rearrange this equation. So we'll take both sides of the equation and divide by 100. So that gives us the relative error over 100. And then we have to take both sides of the equation and multiply by the measurement. And we end up with this equation. If we knew that the error was 56.8 centimeters plus or minus 0.2%, and we wanted to know, well, how many centimeters is that? What we're doing is we're figuring out what is 0.2% of 56.8 centimeters. So you might already be familiar with how to do that. So to figure out what 0.2% of 56.8 centimeters is, you take the 0.2, divide it by 100 to get 0.002, and then you multiply that by the number you're trying to get that percent of. So you're multiplying it by the measurement. And then when you do this, the percent cancels, and so you just have this number, 0.002, times 56.8 centimeters. You come out with an uncertainty that is centimeters. And that is expected because the absolute error should have the same units as your measurement.